Hi friends, now we are going to be discuss about the hybridization of the nitrogen. In the last class, we discuss about the hybridization of the carbon, but here we are going to discuss about the nitrogen. Example, you can take the ammonia. Always to the nitrogen we are showing with the lone pair of electron. Remember that. We are showing with the lone pair of electrons. Then how we can write the hybridization for this one? First we have to be, I given one formula in the last class, that is Z is equal to the type of hybridization, that is Z is equal to valence electrons of the center atom plus monovalent number of monovalent atoms. Now what type of hybridization it is give means, let's see, valence means it is nitrogen. What is the valence electron of the nitrogen? We have to be write configuration 1s2, 2s2, then 2p3. This is the outer shell. Outer shell means how many electrons are there? In that case 5 electrons are there. Then number of monovalent atoms 3. 5 plus 3 8 divided by 2. Then 4 new equivalent orbitals it is going to be produced. What we discussed in the last class, hybridization means mixing of pure orbitals to give set of new equivalent orbitals. Is it? Mixing of pure orbitals to give new set of new equivalent orbitals. Okay, then here how many orbitals they are going to be mixed? 4 orbitals. 4 orbitals means what type of hybridization we can think this one? What type of hybridization? sp3, because 1s 3p, total how many? 4. Then we will check the example, it is sp3 or not. How you are going to be write the structure, then how you are going to be prove that it is belongs to the sp hybridization. sp3 hybridization means what? Here 4 set of new equivalent orbitals, sp3, sp3, sp3. See how many? 4. 1s 3p. 1s 3p mixing together to give the 4 new equivalent orbitals. Mixing of what? 1s 3p produces sp3 hybridization. Okay, that's why it is going to give how many? 4 set of new equivalent orbitals. It is possible in case of what? sp3 only. Okay, I hope you might be understood this one. Now I will go for the hybridization state and ground state. I will write all those things exactly how it will be ammonia. I will write here. This is 1s state. 2 filled electrons are there. When 2s also filled electrons are there. But in this case you might be observing what? 2p3. 3 orbitals also having 1 electrons. All they are filled. This is about the ground state. What about the excited state? Excited state, when it is possible? In case of carbon, excited state is possible. How it will be in case of carbon? This is in case of ammonia. Okay, ground state. In case of carbon, how it will be? 1s, just I am showing the difference. 2s, then 2p, because this one, what is the configuration? 1s2, 2s2, 2p2. Only 2 orbitals is filling, another one is the unfilled. That's why it goes from the ground state to excited state. This possible in case of carbon. It have to be go from the ground state to excited state. Why? To transfer this one of the electron to this empty p orbital. Then in the hybridized state, all together they are going to get the equivalent electrons and equivalent orbitals like this 4. In case of hybridized state, it is going to be get like this: sp3, 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 sp3. But in the excited state, they are going to be like this. All they are going to be filled. This one also going to be filled: px, py, pz, px, py, pz. This is possible excited state. This is the hybridized state. Okay, but in case of this one, any empty orbital you are seeing in this case of nitrogen? No, all 3p orbitals also having 1 electron. You can see 1 1 1 1, all 3. Is it required to be undergo the excited state? No need of excited state for this one. Why no need of excited state required? Means all they are filled. All they are filled. That's why the nitrogen, it won't undergo the excited state. Directly we are writing the hybridized state. In the hybridized state, what happening? 1s, same, it will be remain same. But this, in the sp3 hybridization, what happening? Already I told that one. Ammonia, it is sp3 hybridization, it will be have. How sp3 means 1s and 3p. 1s means this one. See, one of the s. It is having how many? You can see here 2 electrons in this case. But in this case 1 1. That's why this one we are showing sp3, 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 sp3. How many? 4 set of new equivalent orbitals it is going to be produced in the hybridized state. Means what is mean by this one? Why this one will be the extra here? It's nothing but nitrogen always having the lone pair of electrons. It indicates that it is having lone pair of electrons. Okay, that's why it is showing here filled, completely filled this orbital. Okay, one of the orbital completely filled in the sp3. Another 3 are the half filled. Okay, but they are mixing together. This one 2s and as well as this 3p. That's why they are going to be produced what type of hybridization? sp3 hybridization. C1s 3p. But in this case, no excited state. Okay, because already all they are filled. Then what will be the structure you might be thinking for this ammonia? See, I will write the orbital structure for the ammonia. 3 hydrogens are there. They are forming the sigma bond here. Sigma, sigma. Or you can write this nitrogen, what type of hybridization is there? sp3 combined with s orbital. Okay, here also sp3 combined with s orbital. That is hydrogen. Here also sp3 combined with s orbital. Means this nitrogen, what I am going to say, it is having the sp3 hybridization. But in this case, what it will be having here? Lone pair of electrons. See, that is the reason it is also look like tetrahedral angle. Just see, tetrahedral angle it is going to be show. sp3 always what type of angle it is going to be show here? Geometry tetrahedral only. But in case of sp3, especially in the carbon, when it will be having the 4 hydrogens, at that time the bond angle will be 109 degree 0.5 something. But here in this case, the bond angle will be between these two here, it is around 107. See the difference? In carbon tetrahedral 109, but here 107. Why? Means this, whatever the pair of electrons are there, it is having the effect on this orbital. nearby orbitals. That's why they are pushing downside. They are pushing downside means they are coming little bit closer like this. Is it right? They are coming little bit closer like this. That's why the bond angle, it is going to be reduced from the 109 to 107. Okay, it is reduced from the 109 to 107. That is the reason, because this is pushing. ये इसको प्रेस कर रहा है नीचे, effect of this pair of electrons. That's why it is going to be give the tetrahedral angle, but little bit downside it may be, you can see little bit it is punctured. Okay, this is sp3 hybridization. Then when the nitrogen will be shows the sp2 hybridization, we can see that also. See, when the amine in the form of, you can see here, primary amine, what will be the hybridization for this one? When we will use the formula, Z is equal to V, valence electrons are 6. How many hydrogens are there? 2. Okay, when it will be undergoes the especially sp2 hybridization, when it is attached to, when it is in the form of amide here, amide form, that is C double bond NH, then it will be going to be give the sp2. How it will be? Just place the formula, you will become to know Z is equal to, center of the atom here is the nitrogen. Nitrogen valence electrons are 6. Then how many monovalent? Only one, 7. Divided by 2 here. Then 7 divided by 2 means it's come around 3.5. Around 3. Around 3 it is indicate that what? 1s, 2p. It means what type of hybridization it is? 1s, 2p means sp2. Okay, it means this nitrogen especially, when it is attached to the double bond, then it is showing the sp2 hybridization. Okay, now you can see sp2 hybridization. How we are going to be write? Ground state, it will be remain same. Then you can take the excited state, not there for this one. Then you can see the hybridized state. Then here it is mixing of how many orbitals in case of sp2? 1s and 2p. That is px, py and pz. Here 1x, 1s. This is s orbital, it is fully filled. These are half filled. And one it is remain, pz is remain unhybridized. Is unhybridized. It is unhybridized form. Only 2p, that is px, py along with the s. They will be undergoes the sp2, sp2, sp2. Okay, 1s, 2p means 3 set of orbitals. 1s, 2p means total how many? 3 set of orbitals, means it is going to be produce the 3 equivalent orbitals. 3 equivalent orbitals. You might be see here the what generally students they will get the doubt how their equivalents are. Here it is fully filled, here it is half filled. But in the nitrogen, that's why I told here it is having the lone pair of electrons. One extra lone pair of electrons. Always remember that nitrogen having the extra pair of electrons. That's why it is fully filled. This is the sp2 hybridization. Then what will be the structure for this one? How you will be thinking the structure for this one? That is R CH double bond NH. Now I can write carbon. Okay, it is having one is the hydrogen, another one is the R group, this one alkyl group. Okay, the another one here is the sigma bond. It is having one is the sigma bond, another one is the pi bond. Okay, that pi bond means one is remain unhybridized form. Remain unhybridized form in both, in the carbon also and the nitrogen also. That's why I will write here. This is unhybridized. And the carbon, there is no lone pair of electrons. Okay. Now you can see the nitrogen here. See how many hydrogens it will be have? Only one. Okay. Only one hydrogen it is having. Then another one, extra pair of electrons. But it is having extra pair of electrons. This one. Okay. Now this one also having 1 pi bond, means one unhybridized p orbital. I will write here unhybridized. Side to side overlap. Half pi bond is upper side, half pi bond is down side. Like this we can write the structure. Now see what shape it is having. I told that when you are drawing the shape, don't consider this unhybridized orbital. Don't consider. See, I am considering only this. It got no trigonal shape. Trigonal. It is also called as the pyramidal shape. Trigonal or pyramidal shape. Okay, this is about the sp2 hybridization of the nitrogen. When it is possible, when it will be having the double bond. Now we will go for the sp hybridization. How it will be? Ground state, it is remain same. Then hybridized state, you can see here what happened in case of sp hybridization. I will write here. sp hybridization, it is possible in case of molecule like cyanide. That is C triple bond N. You can write this one H also you can take, or R also you can take. Now you can take the formula same. Z is equal to V plus M by 2. Then V, center of the atom. Okay. How many valence electrons are there in the outer shell? 5. 5 plus. Is it any monovalents are attached to this one? No. No monovalents, no hydrogens, no halogens. That's why it will be 0. 5 by 2. It is get around 2. 2.5 means around 2. You have to be think like that. 2 means what type of hybridization? 2 means sp hybridization, because in this case one S and one P. That's why it is going to give the two set of new equivalent orbitals. How many orbitals it is going to be produced by the hybridization? Now you can see the hybridized state. Here it is not going excited state same. Now you can see this one of the s orbital mixing with the one of the p orbital. That's why here I can write one of the s. It is completely filled. This is half filled. Okay, one of the s and one of the p. Then how many it will be remain? Unhybridized. 2 will be remain unhybridized. Which one? Py and pz. Only px it is mixing with the 2s because it is sp hybridization. Okay, now it is going to be produced. That is the reason sp. Here I told, here don't be think like that. Here it is half fulfilled, it is half filled. Then how it will be the equivalent? Because here what it will be having? Pair of electrons, always nitrogen. That's why we are mentioning. Okay, that is the reason it is going to be produced. How many? 2 new equivalent orbitals. That's why what type of hybridization it is called? sp, 1s and 1p. Then we can write the structure of this one, cyanide. Here it is having the R group. Here you can see how many pi bonds? There are 2 pi bonds. One is the sigma bond. That's why it is the triple bonded molecule. Along with lone pair of electrons remain same. Then how you will be write the structure for this one? Orbital structure. it is having one lone pair of electrons. Okay, but unhybridized orbital, how many? On the carbon also, on the nitrogen also, there are how many unhybridized? Two unhybridized, py and pz. Here one unhybridized and here one unhybridized. Here also same. Here one unhybridized, then here one unhybridized. You can see one is called as the py, another one is the pz. On the nitrogen also py, and another one is the pz. This is the R. Okay, now they overlap with each other. You can see here. Then here one pi, half pi, here one half pi, here one half pi, here one half pi. Total how many? 2 pi bonds. That's why it is going to be show what type of sp hybridization. You can draw the geometry of this one. They are linear structure. Linear. Okay. To this also you can draw linear. Linear means what angle they will be having? 180 degree. But it is won't remain 180. Little bit this, whatever the pair of electrons are there, they are pushing, it will be reducing little bit. Okay, but the shape you can say this one. What type of shape they will be having means geometry linear. In case of sp2, trigonal, pyramidal it is called. In case of sp3, tetrahedral. But in case of sp, it is the linear shape it is going to get. This is about the nitrogen, the hybridization of the nitrogen. For sp3 also, sp2 also, and sp also. Okay. But here sometimes it is very complex. In case of amide, I will write. Amide is what? RCO NH2. Generally NH2 means what type of hybridization we will be think for this one? We can say it is the sp3 hybridization. How it is sp3 hybridization? You can see nitrogen valence electrons in the outer shell, how much? Already we wrote 1s2, 2s2, 2p3. This is outer shell, 5 electrons. Okay, then z is equal to 5 plus here how many? 2. Is it right? How many monovalent? 2 monovalent. That's why 2. Then divided by 2. How much it is going to get? In case of amide, what generally we will be think means nitrogen, this one is having the sp3 hybridization because there is no pi bonds here. But this nitrogen, exactly what it is having means it's having the sp2 hybridization. Why it is sp2 hybridization? It will be shows means this delocalization of this electron will be going to take place. How it will be? R minus, here this electrons will be shifting here due to the resonance like this. Now you can see when the electrons will be shift here, then what type of hybridization it is going to be produced? sp2. But here it is look like sp3 because one pair of electron is there, 2 hydrogens are there, and another side it is bonding, means it is going to get the tetrahedral structure, this nitrogen like this, another side binding with this one carbon. It is look like tetrahedral, but it is not the tetrahedral. Due to the delocalization of the electron, it is showing the sp2 hybridization instead of sp3. That sometimes the student they will be get confused. Okay, no need to go that much deeper, especially no for the B form. Okay, that will be for competitive exams like a GPAT and other exams, it is helpful. Thank you very much.